Good morning, all. Today we are going to talk about the topic of design and analysis of algorithm. We already known about what is design and analysis of algorithm, which is nothing but algorithm that can be analyzed by time complexity or space complexity. This is the design and analysis of algorithm. Before to analyze the algorithm, we have to design some kind of algorithm which can solve that particular problem. So that kind of algorithm can give efficient time complexity and space complexity. Those things we have to analyze and find out the best algorithm for that particular problem. So this is the design and analysis of algorithm. So in that design and analysis of algorithm, we are going to see that particular topic, which is traveling salesman problem. The main algorithm approaches of this traveling salesman problem is nothing but brute force, dynamic programming, branch and bound, and genetic algorithm. Brute force, dynamic programming, and branch and bound, those can give the approximate solution, or can give the 90%, 80%, 80 to 85 to 90% accuracy can give that particular problem. But in genetic algorithm, that can give before 85 to 95% of accuracy can give. So the main approaches are brute force, dynamic programming, branch and bound. So this is the main algorithmic approach that can be solved traveling salesman problem. Traveling salesman is nothing but it's kind of problem. How can we solve that particular problem in various types of algorithmic approaches are here, that is brute force, dynamic programming, and branch and bound. The thing which cannot give the exact solution, that can only give the approximate solution, is nothing but genetic algorithm. We should not use that kind of approximate solutions algorithm. So we are going to see that balance three topics, which is balance three algorithmic approaches, which is nothing but brute force, dynamic programming, and branch and bound. So the first one is brute force via permutation. Brute force is kind of permutation method. So here we have to define the brute force methods, what is it, and we can give some length of arrays, that is nothing but n is equal to length, that is distance, and find the best root of that particular length of the array. So for this we have to make some permutation method, we have to give some permutation method for all the root of that each and for all the each and every node. We can give some cost of that particular root. Two nodes connected by a root, that particular root can have some cost. We have to find which can give the best root, that can be calculated by cost of that particular root. So here is a root. Initially root is equal to 0 from plus permission plus 0. It's nothing but the starting point is 0. We can give the permission to start we can give the permission for starting node to reach the next node. So cost, how can we calculate the cost? Means cost is equal to nothing but sum of distance of root of I plus 1 for I in range of n. We can give the n number of roots, n number of nodes. So initially the first node is considered as I. So we can make a move from I to I plus 1. So here we can calculate the distance of root I, nothing but first node, and root I plus 1 is nothing but with the node which can move to the next node, that is I plus 1. We have to calculate this kind of cost until the range of n, which is n number of nodes are there. So if cost is less than best, then best root is cost root. We can give, we already defined which is the best complexity of this algorithm. So if we find the cost of one node to another node, that cost is less than amount of best node, means that particular root is the best. So best root is equal to cost root, return best root. So example, this is the example, distance and 0, 2, 9, 10, 1, 0, 6, 4. This is the cost of that route that can be connected by one node to another node. So this is the example. Oh, thank you. We'll see the next algorithmic approach in next video.